Hi, welcome to everyone for the course Wind and Seismic Analysis, in which myself I am Ghanshyam Gupta, Assistant Professor Tech Q, Department of Civil Engineering, Government Engineering College, Jhalawar. In this module, we will study what are the structural systems. So, the outline of the module on structural analysis systems is firstly introduction and what are the building structural systems. Another one is type of structures and its form. Third one is aspect ratio, and fourth one is overturning resistance. Overturning resistance means how the building will behave when it is subjected to a lateral force. And last one is a strength and stiffness. So out of these five we will have study only two out of them. One is introduction and type of structure and structural forms, and rest of three are we will cover. I will cover in next lecture. So first is introduction. What are the building structural system? The term structural system or structural frame is referred to the load resisting subsystem of a building or object. The structural system transfers load through its interconnected elements or members. Interconnected elements means it's connected through a beams and columns and then footings. The structural systems or structural frame can be defined as the assembly of interrelated or interdependent elements which form a complex structure, and they are designed and built for resisting different type of loads. The element of a structural system can also be related to the bones of the human body. If I am giving you an example, then we can consider it like bones in a human body. If the bones are weak and not properly aligned and integrated into a human body, then the human body will not be able to perform well. So like in the same manner, if the structural systems are not proper, then it would not be able to take the loads. Now the next slide is type of structural and structural forms. What are the different type of structures? So number one is load bearing systems, another one is a framed system, third one is shell system, and last is strut and tie. Out of these four, today we will study only two types, that is load bearing systems and frame system. Shell type of structures will be covered later on in a brief, and last one strut and tie, as you have already studied in your subject steel structure, so I will not cover these topics. So now number one, load bearing systems. What are the load bearing systems? So it's a structural system where load of building, that is weight of building itself plus the live load, get transferred to the ground through the walls, or the walls are of masonry walls or stone masonry walls or brick masonry walls. Walls bear the load of roof, floor, and of course self-weight. Self-weight means it's the load of dead load of masonry walls. Okay, so here is a diagrammatic representation of load bearing systems, in which you can easily see the brick masonry walls are subjected to a roof slab, and below which it is subjected to a floor slab, and here you cannot see any type of beams and columns. So the load acting on a roof or its self-weight of a roof is directly transferred to the masonry walls, and through that masonry walls it is directly transferred to the subsoil strata, which is a soil. Okay, so in which the load is directly transferred to masonry walls, and then masonry wall transferred to the ground surface. Now second one is framed structure system. In a framed structure system are the structures having the combination of beam, columns, and wall and slabs to resist the lateral and gravity loads. Lateral loads means it's a type of a wind load or it's a earthquake load. Okay. These structures are usually used to overcome the large movement developing due to the applied loading. So these type of structures are subjected to a huge amount of movement or huge amount of load. That's why these type of structures are built. So what are the components? Suppose if I am talking about the components of framed structural system, so what are the components of framed structural systems? Framed are generally used in buildings, okay, and these type of structures are composed of beam and columns, and they are either pinned or fixed connected like a truss structures. So here these are differentiated into two parts. One is a rigid framed structure and another one is a braced frame structures. So in rigid framed structure there are two types of structures. One is pin-ended and another one is a fixed-ended. In a braced frame structure these are also of two types. One is gable frame and another one is a portal frame. So this is a pictorial view of framed structural system in which you see the slabs, beams and columns are interconnected, and the load of the slab is directly transferred to its surrounding beams, and then beam transferred load to the its interconnected columns. Then columns transfer this load to the foundation and foundation to the soil strata. So this is a load path flow of framed structural systems. Okay. Now I am talking about rigid frame structures are of two types. One is pin-ended frame and another one is a fixed-ended rigid frame. So what are the rigid frames? Rigid frames are the structure in which the deflection, even after deflection, the angle between the beam and column remains same even after deflection. So in this you can easily see the angle between the beam and column is 90 degree, and after deflection or deformation this angle would remain the 90 degree after deflection. So these type of frames are called rigid frames. Here there are two types. One is pin-ended rigid frames and another one is a fixed-ended rigid frame, in which you can see the columns ended are connected to a pin-ended, and in which here you can see the columns are connected to a fixed. Okay. Now braced frame structures. Braced frame structures are of two types. One is portal braced frame, another one is a gable frame. So portal braced frame is in which you can see an inclined member is connected to a portal frame. This inclined member is called bracing. So that's why it is called a braced frame structure. Suppose if any structure is subjected to large amount of load, so there will be a chances of deflection of that beam and sway of that columns. So to prevent this, we can provide a bracing at a 45 degree angle or any other angle may be used for your convenience, but as a design purpose. But we can provide, if we provide an inclined bracing into that system, then it will take more load. So it's a portal braced frame system. Another one is a gable frame system. In a gable frame system, you can see that along the length of a structure, these are of members are called purlins. These members are called purlins. In which diagram you can easily see the purlins. These are the purlins, and along the width, the end corners, the end members are called rafters. Okay. Or here here it is easily see the gable columns and gable girth. Okay. So these are the structures which are of shelter type structure, and these structures are used in as a cold storage or a very big structure, and these structures are a single story type structure. Okay, next. So what are the difference between load bearing structures and a framed structures? So load bearing structures and a frame. So if we are talking about in terms of components, so these structures, load bearing structures having heavy masonry walls of brick and either brick or stone, whereas in a framed structure they are having a components of beam, column and slab. Load transfer path, how the load is transferred in both type of structure. In load bearing structure, the slab load is directly transferred to the walls and walls to the load bearing footing, that is the soil. In a framed structure, the slab load transfer to its interconnected beams, and then beams transfer the load to the columns, and then column transfer to the load to the footing, and then it will transfer to the soil. Now, what is the resistance to earthquake? If these two type of structure are subjected to a earthquake, then how it will behave? So load bearing structure is poor resistance to earthquake or lateral loading, whereas the framed structure are more resistant to the earthquake loading. Why? Because load bearing structures are heavy structures, and they are of the load carrying members are masonry walls, so they can easily destroy or easily destructive in nature, whereas the framed structures are maybe of ductile in nature, so they can resist more earthquake or more lateral forces. And if we are talking in terms of thickness of wall, then load bearing structures, in which load bearing structure the thickness of wall are more, whereas in framed structure the thickness of wall are less. Corporate area, so definitely if the walls are thicker, then less area will be available, and if the walls are thinner, then more area will be available in a framed structures. And what about the speed of construction? So the speed of construction in a load bearing structure is less in compared to the framed structure, and material required, obviously material required. So if the walls are thicker, so material will be more, and if the walls are thinner, the material will be less. Except of these, there will be many more differences, like height of structures. So in the case of load bearing, which I am not mentioning here because they are not required, but I am telling you the height of structure. So in load bearing structure, the height will be limited. In a framed structure, the height will be a more. As you can see, a 40 story buildings, 50 story buildings, all the multi-story buildings are of framed structure and not load bearing structures. Another one is if I am talking about walls constructions. So load bearing systems, in load bearing structures, the beams and column are not there, hence the wall have to be built first. In load bearing system, the masonry walls to be built first, and in a framed structures, all the beam, column and framed structure to be built first, then after the walls to be constructed. Okay. Now excavation, if I am talking about the excavation, then load bearing structure, in a load bearing structure, excavation will be a more, because the load bearing walls will be constructed below the ground level, and in the frame type of structure, excavation is required only for the columns. Labor requirement, if I am talking in terms of labor requirement, load bearing structures, labor required will be more, and in a frame structure, labor required will be less. So these are some differences in a load bearing structures and a framed structures. Okay. Now these are some references that you can refer for this lecture and go through this. So thank you.